All right, here's your second video for chapter 9, section 4 of your book. This is talking about angles of elevation and depression. So finally here, we're going to get into real life applications of these triangle problems that we've learned. So what is an angle of elevation or angle of depression? It is just an angle that is created by a line of sight, either looking upward from a vertical line or looking upward from a horizontal line or downward from a horizontal line. So if you're looking upward from a horizontal line, that's an angle of elevation, and downward is an angle of depression. Here are the definitions of them if you want to write them down. But you can see in our diagram here, as the guy looks down at the cat, that's an angle of depression. As he looks up at the airplane, that's an angle of elevation. And so, like I said before, there are a lot of real life applications of these. So you see in this picture a couple of surveyors. You may have seen them out and about in cities and stuff, measuring different angles, finding level planes, things like that. So the tool that you see them using here is called the transit. And this is something that they do as a part of their job every day. So here you're actually looking at a picture that I took when Ms. Papke and I visited Dubai. And so in this picture, I am standing in the observation deck of the tallest building in the world, the Burj Khalifa. And that observation deck is 452 meters above the ground. That's over a quarter mile up into the air. And so you can see right here, you've got the shadow of the building right here. And that shadow is approximately 879 meters long. I actually measured it using Google Maps to this point on the road where it was. And so the question is, what's the angle of depression as I'm looking down, right? Because I'm looking down at this point right here. What's the angle of depression from the observation deck to the end of the shadow? And so the first thing you want to do whenever you get a problem like this is to draw a diagram. So for example, we've got the building and we've got the shadow. So the building is 452 meters tall. Well, actually, the building is taller than that, but the place that I am standing in the building is 452 meters tall. The shadow is 879 meters long. Let's complete the triangle and then think about what we're trying to find. There's our horizontal line. And we've got an angle there, X in the triangle, and then also there an angle Y. So angle Y is what we're trying to find. That's the angle of depression down from the horizontal line. But in order to find Y, we're going to actually have to find X first, because X is actually an angle of this triangle. So how are we going to do that? We're going to do that using techniques we already know, using inverse trig functions. 879 is opposite X, 452 is adjacent to X. So which inverse trig function should we use? We should use tangent. We do tangent inverse of that ratio. We get an angle for X. Angle X plus angle Y is going to be 90 degrees. This is a right angle right here because this is a horizontal line to the ground. And so if we do 90 minus 62.79, we get our answer. So the correct answer here, the angle of depression, I'm looking down at an angle of 27.21 degrees. All right, let's look at another problem. An airplane is going to take off and rise at an angle of elevation of 7 degrees until it reaches its cruising altitude of 30,000 feet. So how far has the plane traveled in order to reach that cruising altitude? And we're going to report that in miles. So we're going to work in feet, and then at the end, we'll convert our answer to miles. So again, let's draw a diagram. The plane takes off at an angle of elevation of 7 degrees. Again, we're going to complete the triangle. That altitude is 30,000 feet up. What are we trying to find? We're trying to find the distance the plane traveled, right? The plane traveled this hypotenuse of the triangle. How far did the plane go? Well, how could we do this? Well, we've got a 7-degree angle here, and we've got two sides we're thinking about, an opposite and a hypotenuse. What trig function is opposite over hypotenuse? It's sine. So sine of 7 degrees equals 30,000 over X. We're going to solve our X just like we learned how to before, multiplying by X, dividing by sine of 7. So that's going to give us an answer of approximately 246,165.27 feet. However, like I said, we want to report this in miles. If you tell somebody 246,000 feet, it's kind of hard to think about how far that is. Miles is more useful. So let's divide by 5,280 and we get 46.62 miles. So it takes the plane almost 50 miles to reach its cruising altitude of 30,000 feet. All right, one more problem. Two buildings are 300 feet apart. The angle of depression from the top of the taller building to the top of the smaller building is 20 degrees, and the smaller building is 120 feet tall. How tall is the taller building? So this sounds kind of like a complicated question, but let's draw a diagram and see if we can make it a little simpler. So we've got two buildings, a shorter building and a taller building. It's 300 feet between them. The shorter building is 120 feet. So that's some of the information we have. The other piece of information we have is that the angle of depression from the top of the taller building to that of the smaller building is 20 degrees. So here we need to have a triangle, right? We've got a quadrilateral here. Well, where's our triangle? Well, it's right there, right? This is 300 from here to here. And we know that that would be a 70-degree angle. We talked about how these two angles here would have to add up to 90. And we want to know total how tall this building is. Well, we know this part right here is 120. So if we can figure out this part right here, we'll know the height of the whole building. So we're going to deal with this triangle here and try to solve for x. And then once we have x, we'll add 120 to our answer. So 300 is opposite 70. X is adjacent to 70. So we're going to use tangent of 70 equals 300 over x. We're going to solve for x. Multiply by x, divide by tangent of 70. Put that in our calculator. We get x is 109.19 feet. That means to find the whole total height of the building, we need to do 120 plus that answer, and we get our final answer of 226.19 feet.